Hello, everybody. This is Mr. Kowalczyk here, and today we're going to do triangles in the coordinate plane, which is Geometry Unit 6, Lesson 4. I was asked by Ethan Altamari to speak a little bit slower during the videos, so I'm going to try to do that, and hopefully you all can keep up and take some notes. So first off, Standard 10.3 says I can use my knowledge of triangles and triangle problems in order to solve problems within the coordinate plane. So first off, for the opener, what I'm going to ask you to do is to pause the video for a second and see if you can determine what type of each triangle is here for A, B, and C in as much specificity as possible with sides and angles, and then write down how you know that. All right, hopefully you paused the video and figured it out. So here we've got these two tick marks. Those mean that these are congruent sides. That tells me that I have an isosceles triangle because of two congruent sides. I can also look at this triangle and recognize that this angle, and this angle are going to be acute. They do not look obtuse, and I don't have any right angle symbols. So in this situation, I have three acute angles, and so I have an acute triangle. And I could be more specific by saying I have an acute isosceles triangle, either way. For B, what type of triangle is below? Well, this is going to be a right triangle because it has one right angle. That's a 1, not an L. And then I can also look at this and I can see that I don't have any tick marks like I do in the other triangles. So therefore, I can also call it a scalene triangle. No congruent sides. And then here for the last one, for C, what type of triangle is this? Well, I have 1, 2, 3 congruent sides. So that's going to give me an equilateral and equiangular. Because when I have one, I have the other. If it's equiangular, I have an equilateral and vice versa. Because of 3 congruent sides. Okay. So why did we do this? Well, we wanted to help remember isosceles, right, and equilateral triangles for today's lesson. And it's going to be important for what we're doing today. All right, now using these rules, what we've learned in the previous lessons in terms of distance and slope, parallel and perpendicular, and congruent, we're going to determine what type of triangle is graphed in the coordinate plane. So follow along with these notes here. Now determining what type of triangle is graphed in the coordinate plane. Well, first, this is a step-by-step process here in order to figure out what type of triangle we have. So what's our initial step? We're going to use the Pythagorean theorem to find the length of all 3 sides. And then we're going to compare the lengths of the 3 sides. If they're equal, then the sides are congruent. Well, we know that. If the lengths are not equal, then the sides are not congruent. They are and are not congruent. That's going to be important comparisons. If no sides are congruent, then you have a what type of triangle? Yep, it's a scalene triangle. And if 2 sides are congruent, as we saw up above, then you have an isosceles triangle. If 3 sides are congruent, then you have an equilateral, equiangular triangle. Then after that, we're going to use rise over run to find the slopes of all 3 sides. We're going to do that to determine if we have parallel or perpendicular. If any slopes are opposite, reciprocals, we know that those sides are perpendicular, and you have a right angle. Okay, now opposite reciprocals, for example, we could have -5/2, and the opposite reciprocal of that would be flipped, so 2/5, and it would have an opposite sign. So if this is negative, then this one would have to be positive. So these are examples of perpendicular slopes. Okay, let's flip over to the next page. We'll do our first sample problem here. Okay, so we have a triangle graphed in the coordinate plane, and I'm looking at this triangle, and just by appearances, it looks like it could be isosceles, and this angle here looks like it could be a right angle, but I'm not sure, so I have to check to make sure. So what we're going to try to do is figure out what type of triangle we have. First, we're going to use the Pythagorean theorem to find the length of the three sides. Now, in order to find the length of the three sides, I'm going to go about it by building that right triangle in order to solve for distance. So got a different color here, and I'm tracing my rise and my run to get from one point to the other, in this case, A to B. This is going to be 1, 2, 3, 4 units long, and this one's going to be 1, 2, 3, 4, 5 units long. And then I'm going to do the same thing from A to C. 1, 2, 3, 4 units long, and then 1, 2, 3, 4, 5 units long. Now these are right angles because I use my horizontal and verticals. So I know that I can use the Pythagorean theorem. This situation down here is different because from B to C, I don't have any rise. It's just a run. So I go 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units long. Therefore, I know that BC is just going to equal 8 units long. So I don't have to use the Pythagorean theorem in that case because it's just a horizontal. All right, now I want to show you one thing before I move forward here that you may not have seen before or remember if you had been shown it before. We know that the Pythagorean theorem tells us that a squared plus b squared equals c squared. And if where c is the hypotenuse, right, the longest side of the right triangle, if I wanted to solve for just c, we know that to get rid of a squared symbol here, the opposite of that is square rooting something. So if we square root both sides of the equation, it will stay the same. And on this side here, this square root and squared will go away. So then what we can do is we can say that c is equal to this thing over here, which is the square root of a squared plus b squared. Okay? Now, first we have to evaluate everything inside of the square root, and then we can take the square root. But this square root here does not just automatically get rid of this squared and that squared because they're added together. You're not allowed to just take those away. Okay, so that's an important thing. I'll show you what that looks like down here. All right, so let's check it out here. Now we have AB, and we know that the two legs of our triangle are 4 and 5. So from our formula above, we can say that AB is equal to the square root of a squared plus b squared. So that's going to give us the square root of 5 squared plus 4 squared. And remember, a and b don't matter where they are, first or second. This is going to be 25 plus 16. 25 plus 16 is going to give me the square root of 41. Now I could evaluate this and find out what the decimal value is, but I'm not going to do that because the square root of 41 is just a number. It's going to be a decimal number. That's a little bit less than 7. So I'm just going to leave it there as the square root of 41 and see what happens with CA if we do have an isosceles triangle, which we should because the legs of our triangle are the same. So again, we have the square root of a squared plus b squared equals the square root of 5 squared plus 4 squared, which is going to equal the square root of 41. So we see that these two legs, CA and AB, are the same, which means they're equal and congruent. And then down here, we come down to number 2, and we say, what choices works here? Well, no congruent sides means it's a scalene. 2 congruent sides means it's isosceles, and 3 congruent sides means it's equilateral. So therefore, we're going to circle the matching situation, which tells us that we have an isosceles triangle. Now for 3, we're asked to use the rise and run to find the slopes of AB, BC, and CA. Let me zoom out a little bit here. And we want to find out if we have a right angle with perpendicular slopes. So AB is going to go from here to here. So my rise is going to be a -5 because I'm going down from A to B. and a -4 because I'm going to the left as well. So that's going to be -5 over -4, which, as you know, simplifies to 5/4. All right, now BC does not have any rise, as we said before, so that's going to be 0 over 8 because the run is 8 in this situation. And finally, C to A is going to be a rise of 5, so that's +5 because we're going up, and a -4 because we're going to the left. So that's 5 over -4. Now what I'm looking at are these two slopes here, 5/4 and 5 and -4. Excuse me, 5 over -4, because those are the ones that I think might be perpendicular to each other, AB and AC. But unfortunately, they're not, because they're not reciprocals of one another. So while this is negative of that, and they have opposite signs, they're not negative reciprocals. Therefore, I can look down at my bottom and say, no, I do not have a right angle. And then I use my clues from here and here to determine what type of triangle I have. I have an isosceles triangle. And I can't say if it's acute or obtuse because I really don't know the measurement of this angle. So I'm just going to leave it at that. You're not required to say if it's acute or obtuse. All right, our last problem for today is determining whether if triangles are congruent when graphed in the coordinate plane. So in this situation, we have two triangles, and what we're charged with is figuring out whether or not they're congruent. So let's figure out through this step-by-step process how we can do that. So first, we're going to use the Pythagorean theorem to find the length of, and in this situation, we have 1, 2, 3, 4, 5, 6 sides. All 6 sides. Okay. All right, y'all. And Ethan, I'm trying to speak slowly. I hope this is working well for you. Compare the lengths of the 3 sides. If they are equal, then the sides are congruent, right? We talked about that. If the lengths are not equal, then the sides are not congruent. Pretty straightforward. If all 3 sides are congruent, then you have, oh, that's a typo. If all 3 matching sides are corresponding, right? If the 3 sides that match up with each other. If all 3 matching sides are congruent, then you have a pair of congruent triangles. If they are not congruent, then you do not have a pair of congruent triangles. Okay, so we basically have to find the distance of all 6 sides and then see if we have matching pairs of congruency. Let's go ahead and do that. All right, now I'm going to draw my right triangles here so I know the distances of my legs. So this is going to be 2, and this is 1, 2, 3, 4, 5. Then we go across and up. This is going to be 1, and then 1, 2, 3, 4, 5, 6, 7, 8. And then we come from C to B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so now we have our legs for that. So we have AB. A to B is 1 and 8. So that gives us the square root of 1 squared plus 8 squared, which equals the square root of 1 plus 64, which is the square root of 65. Okay, now BC goes from here to here, and that's going to be 6 by 6, 6 squared plus 6 squared, and that equals the square root of 36 plus 36, which is equal to the square root of 72. And finally, CA is 2 and 5. So that gives me the square root of 2 squared plus 5 squared equals the square root of 4 plus 25, which is equal to the square root of 29. Now remember, these 3 legs, 65, 72, and 29, don't have to equal each other, but they have to match up with 3 legs from this triangle here. So let's go ahead and see if they do that. So now I'm going to build my right triangles with my triangle XYZ. Now I'm going to count. I have 2, So Z is 2, that's 2. 1, 2, 3, 4, 5. It's 5, all right? So that seems to match up. Now we got 1 by 1, 2, 3, 4, 5, 6, 7, 8. That matches up. 1, 2, 3, 4, 5, 6. Ooh. 1, 2, 3, 4, 5, 6 by 6. All right. So now we have xy, which is right here. That's going to be the square root of 1 squared plus 8 squared, which, as we saw from over here, is equal to the square root of 65. And then yz right here is 5 squared plus 2 squared. And as we saw down here, that's going to give us the square root of 29. And then let's see what else, 6 and 6. Square root of 6 squared plus 6 squared is equal to the square root of 36 plus 36, which is equal to square root of 72. Now what I have is matching pairs. 1 matching pair, 2 matching pairs, and 3 matching pairs, which is exactly what I'm looking for to prove that the triangles are congruent to each other. Awesome. Okay, so finally down here, if all 3 sides are congruent, then you have congruent triangles. Wonderful. Okay, that's all for today. Hopefully you got all these notes finished up, and then we'll practice some more in class next time we see each other. Have a great day.